Hello everyone, welcome to this new video from Guidancee education channel. In this video, we are going to discuss laws of chemical combination. There are altogether 4 laws of chemical combination. Law of conservation of mass proposed by Lavoisier in 1789, law of definite proportion proposed by Proust in 1806, now known as Proust law, law of multiple proportion proposed by Dalton 1803, and Gay-Lussac's law of gaseous volume proposed by Gay-Lussac in 1808. There is not much of a difference in the years in which they were proposed. We will discuss the laws one by one. The fundamentals of chemistry were built on these basic laws. So, these laws are very important. So, this video is going to be of great use to you. So, watch the video completely without skipping. And if you think the video is useful, like the video, share the video, and also leave your comments in the comment box below. If you are watching the video without subscribing to my channel, please do subscribe my channel and also press the bell button so that you get intimated as soon as videos are posted. Your subscriptions will be a great motivation for me. Thank you very much. Now let us discuss first law of chemical combination, law of conservation of mass proposed by Lavoisier. The law states that matter can neither be created nor destroyed in a chemical reaction. This can be experimentally proved using a simple experiment where barium chloride reacts with sodium sulfate to form barium sulfate and sodium chloride. I have given here 2 pictures. The first picture marked A is the initial stage and B is the final stage. Initially, the barium chloride is taken in a test tube and it is arranged inside the flask which contains sodium sulfate, and it is kept in such a manner that the reagents do not come into contact with each other. Its weight is first taken and it is noted. Then the flask is slightly tilted so that the reagents come into contact with each other and the whole of barium chloride and sodium sulfate get used up and barium sulfate and sodium chloride forms. After the experiment, the system is again weighed and its mass is also noted, and the initial mass and the final mass are compared. The initial mass is the mass of reactants and the final mass is the mass of products. The experiment is done with utmost care so that there is no error and the values can be trusted. It is found that the initial mass of the system is equal to final mass of the system, which suggests that matter was neither created nor destroyed during the process of the chemical reaction. Now we will write the balanced chemical equation for the reaction. BaCl2 aqueous plus Na2SO4 aqueous gives BaSO4 solid plus 2NaCl aqueous. So barium sulfate is formed as a precipitate. We will pass on to the second law. Now we will discuss the second law of chemical combination, namely law of definite proportion proposed by Proust. The law states that a given compound always contains the same elements in the same proportion by mass. By proportion we mean ratio. He studied cupric carbonate. He collected 2 samples of cupric carbonate, one natural sample and another synthetic sample, and studied the mass percentage, that is percentage composition of the various elements present in that compound, namely copper, oxygen and carbon. And in both cases he got identical results, that is the mass percentage of copper, oxygen and carbon were the same irrespective of the source from where it was collected. You can see that from the chart that I have provided here. It is similar findings that led to the proposition of this law. Okay, but anyway, further studies on law of definite proportion showed that this law had certain limitations. There were 2 limitations cited. What are they? If the elements present in the compound were isotopes, then this law did not apply. So also, when two or more compounds had the same molecular formula, then also this law did not hold good. For example, C2H6O is a molecular formula. Two compounds, C2H5OH, this is ethyl alcohol, CH3OCH3, this is dimethyl ether. These two compounds have the same molecular formula. That is, in both these compounds, carbon, hydrogen and oxygen are present in the same ratio, but they are two different compounds. So, two different compounds having same molecular formula. In such cases, this law did not apply. Even then, this law is still accepted as a basic concept because in all other cases, the law holds good. This law is known as Proust's law. Okay, I hope this is clear. Now let us discuss the third law of chemical combination, law of multiple proportion proposed by Dalton. It states that when two elements combine to form more than one compound, the mass of one element combining with a fixed mass of the other element are in the ratio of small whole number. Let us take for example water and hydrogen peroxide. Elements present in both these compounds are oxygen and hydrogen. In the case of water, 16 grams of oxygen combined with 2 grams of hydrogen. In hydrogen peroxide, 32 grams of oxygen combined with the same amount of hydrogen, 2 grams. So what does the law state? Mass of one element combining with fixed mass of the other element where a simple whole ratio, that is 16:32, can be simplified as 1:2. That is what the law states. This is very simple. It can be easily understood. I hope it is clear. Now let us discuss Gay-Lussac's law of gaseous volume. This is the fourth law under laws of chemical combination. What does the law state? It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Let us try to understand this law. The reacting substances are gases and the products are also gases, and their volumes are considered, and their volumes bear a simple ratio. All measurements have to be taken at the same temperature and pressure because the volume of gases depend very much on temperature and pressure. You have already learned gas laws in your smaller classes. Now let us take one example in order to understand this. From the balanced equation, 2 volumes of hydrogen combine with 1 volume of oxygen to produce 2 volumes of water vapor. Because the law states gaseous state. What does this mean? If 2 liter of hydrogen is reacting, then it requires 1 liter of oxygen and 2 liters of water will be formed. I have just prepared a diagrammatic sketch here. 2 liters, half of that, 1 liter, then 2 liters. This is for hydrogen, this is for oxygen, and this is for water vapor. This is a very simple law. And in essence, it resembles law of definite proportion. Avogadro studied more about this law and gave more explanation for this law. We will be learning Avogadro's law and Dalton's law in the coming video. Those two laws are not really included under laws of chemical combination. I hope these points are clear. We will meet in the next video. Thank you very much.